Let's discuss distinct subsequence problem. Given two strings s and t of length n and m respectively, find the count of distinct occurrences of t in s as a subsequence modulo 10 raised to 9 plus 7. Example, if s is banana and t is ban, the output is 3. Because in banana, ban can be formed using the first three characters, first ba and this n, first b and these two an. If the question it was mentioned that, to find distinct occurrences of t in S as a substring, then we could have used sliding window approach. Because substring is formed from adjacent characters. Since it is mentioned as a subsequence, we need to consider strings which are formed from adjacent characters as well as non-adjacent characters. So we need to consider all possible combinations. Since we need to find all possible combinations, that means we have to use a recursive approach. And finally, the recursive approach has to be implemented using a dynamic programming. For a recursive solution, we need to find two things. One is the base case and the recursive function. Let's see what is the recursive function in this case. We know that s is equal to banana and t is equal to ban. Let's see how we can form the recursive function. If we are getting two strings, then we can first compare the first two characters and check if both of them are equal. In this case, we can see the both of the characters are equal. Since b is equal, we need to check if an is present in the remaining characters of s. So, if we got a match between the first characters of s and t, then we have to again call the function. For example, if we have the function which takes st, and if s of 0 is equal to t of 0, then again we have to call the function with s and t. But in this time, we need to check if the string that is starting from index 1 in t is present in string that is starting from index 1 in s. That means we have to change the index to 1, 1. Here, the initial index that we are considering is 0, 0. If the first characters are not same, then in that case, we need to check if the whole ban is present in the remaining characters of s. So, in case if it was not present, if it was not equal, we need to again call the function recursively. During this time, we have to pass st, and the first character, the s should start from first index and t should start from the 0th index. Consider a scenario in which s was like this. In this case, even if we find a match in the first two characters, we need to check for there is a match in the second character as well. So, even though the first two characters are first characters of both strings are equal, there is a possibility that a match could occur in the remaining string as well. So, in this case also, we should call the function with st, and index of s should start with 1 and the index of t should start with 0 itself. So, this is the recursive function. If we are writing it generally, we can write like function st, index of s, the starting index of x and starting index of t, that is j. And the recursive function would look like if s of I is equal to t of j. That is, s of I, the first character of s and first character of t are equal. In that case, we should call the function again with the index incremented by 1. And in this case, we should increment it by 1. We can see that this function is called with same arguments. So, instead of using an else loop, we can just write it as a common call. We have to pass I plus 1 over here, but here we need to pass j. This is the recursive function. Now, in order to check the base condition, we can check what are the possible values of I and j. Initially, when we call, we will pass I and j as 0, and both of them will get incremented at some point. J will get incremented, that is, index of t will get incremented only if we find a match in character with s. That means, when j becomes the length of t, that means we got a match of the whole string t in s, because j is getting incremented only if we find a match. That means we got a match and we have to return 1 in this case. If j didn't reach at the end, like j didn't reach to the length of t, but I reached to the length of s, that means we reach till the length reach till the end of string s, but we couldn't find a match for t. That means we have to return 0 in this case. So this is the recursive function and base condition. Using this, we need to write the code. So this is the main function which is taking the string s and t. Initially we have to call a function, and I is 0, j is 0, we have to pass string s and t. Since we have to return the answer with modulo 10 raised to 9 plus 7, we have to do this operation. The sol function is taking 4 parameters I, j, s and t. I is index of s, j is starting index of t. Here we are writing the base condition that j, index of t, reached the length. That means we have found a match, we have to return 1. If I reach the end of string s, we didn't find a match, we have to return 0. Now we are writing the recursive condition, recursive function. So we have to check if the first characters of both the strings are equal. If they are equal, that means we found a match for the first character. We need to check for the remaining characters of t in remaining characters of s. So we have to again call the function with incrementing I, j and passing s and t. There is also a chance that even if we find a character match, we can again find the first character in the remaining part of string s. So we have to call the function again with I plus 1, that is remaining part of s, and the whole t. And finally, since it is a recursive function, we have to add up the count to find all the possible combinations, and finally we have to return the count. In order to solve it using a dynamic programming, we know that here we can see two parameters are changing. That is, the index of s and index of t are changing together. So we need to include a 2D matrix to store the pre-computed values. So we can declare a two-dimensional DP array, and its length is s.length plus 1. Because if we are declaring a s.length plus 1, the final index number will be s.length. So we can see here that j can reach till t.length and I can reach till s.length. So we have to create a two-dimensional array with s.length plus 1 and t.length plus 1. Initially we have to fill all the values with minus 1. Whenever we are solving the function with a particular value of ij, and we have to store the result in the two-dimensional DP array. So DP of ij is equal to count after finding the count. But we are using DP so that we don't need to compute the results again if we have already solved it. So if we have called function sol with I as 3 and j as 2, and it is already computed, and if it is already present in the DP of 3, 2, then we don't need to compute it again. We just need to return the value. So we have to add one condition. If DP of ij not equal to minus 1, we have to return the DP of ij. So this is the solution using dynamic programming.